So to do that, do I need to do square root of 600 squared plus 120 squared?
For the angle of elevation?
Oh, that's the so do I? Sorry, do I need to then? Do I need to put in the number 600 for x and 120 for y?
Yeah.
And then do I then do like sine rule?
You could use SOHCAHTOA as well.
So will that just be will that be opposite over adjacent?
Mm-hmm.
So tan theta is equals to 120 over 600.
Mm-hmm.
And then I need to do arctan of that.
Mm-hmm.
And then that will be I got like 11.3.
Okay. 11.3 degrees. B.
So do I need to sub in 50 for V?
Yep.
And so that will be x is equals to 50 cos theta and y is equals to 50 sine theta.
Yeah, and don't forget the T at the end.
Okay.
What is theta?
And theta is 11.3.
Yeah.
And so it'll be y is equals to 50 sine 11.32.
Yeah. Maybe we better do that. What was 11.3 to 5 sig fig?
11.30. Oh no, 11.310.
Okay, so just for working out those ones. Okay. And C. Or maybe just in case, what would these be to 3 sig fig? So 50 cos 11.310.
I got. Shall I give it 40? So for the first one, I got 49.0.
49.0 T. And I got 9 point. So 9.8059. 8059 T, just so we have it for the working out. Question C.
So I'm guessing I need to sub in 10 for T here.
Yep.
Do I need to do 9.8059 times 10?
Yep.
And so will that just be 98.059?
I believe so. And so that one, we can say 98.1. I don't think we need to use that for anything.
Yeah.
This is height. This is meters. D.
Do I need to take two coordinates here or something?
Two coordinates. If you connect two coordinates, it'll always make a straight line. Any other ideas?
Do I here need to do like square root of 600 squared plus 120 squared. So it's like a displacement, or
so I'm not sure if that would prove it. I might be wrong, but I think you have to find the Cartesian equation. So combine the two into one normal one.
do I need to then eliminate t or something?
Yeah. Maybe I'm wrong about that. I would have thought. Yeah, okay. How would you go with that one?
So do I need to do x over 50 cos 11.3 equals to t?
You'd need to do it in general. So it would be x over vt equals cos theta. Any idea about why?
So do I then need to do y over vt equals to sine theta?
Yeah, hang on. I was going to say square both of these, but then you still have t. Maybe I'm not eliminating the right thing. Well, maybe one of your ideas was maybe this is overkill. Maybe it's just a simple thing. I'm just trying to think, how do you show that it's a straight line? Prove that it's a straight line. So you couldn't find the Cartesian equation. If we're finding the Cartesian equation, we have to eliminate t, but we also have to eliminate theta, but we know theta. So x is 49t, y is 9.81t. Okay, what is Cartesian equation then? If we did it that way, yeah. Sorry, it's simpler than that. So x is 49t, y is 9.81t, and we want to make one equation.
Do I need to then do x over 49 equals to t and y over 9.81 equals to t?
You can do the x one is fine. That's all you really need.
I then just sub in x over 49 to do y equals 9.81 times x over 49.
Yeah, and actually maybe I'll just do 8059 to be more accurate. X, oops, over 49. I mean, it's not in the simplest form. Okay, 0.2. Y equals 0.2x. And what do you have to say at the end?
So therefore, the plane of motion is a straight line.
Maybe that's enough. Yeah, because it's in the form y equals mx plus c. E.
So is it just because time is never negative?
No. T is greater than 0 is never negative either.
is t. Um. Oh, do I need to work out the domain here? Do I?
No. What if t was 1,000,000?
That would make. Well, I'm guessing that's too big or something.
Why? What would happen to the plane?
If it was 1,000,000, so that would be. Do I need to sub in all the values for v and theta?
Nope. The plane can't climb forever.
Oh, right.
Climb forever. And so like t needs an upper bound or something like that.
Yeah.
So with pure maths, t is great. You said it can't be negative. So t has to be greater than 0. So that's like pure maths, great. Real world, applying it to real world, t can't just be any value bigger than 0. You do need some kind of upper bound. Otherwise, the position of the plane wouldn't be correctly modeled. Let's see. So 11.3. So that was arctan for that one. So sine rule would have worked as well. Simpler SOHCAHTOA. This one, 49.0t, 9.81t for those two. That was v cos theta, v sin theta. Sub in 10, you get 98.1. Yes, so you use those values and sub them in, and then you eliminate t. 0.2x. Since this is a linear equation, the motion of the plane is a straight line with a gradient of 0.2. T is greater than 0 is not realistic, as this would mean the plane would continue climbing forever at the same speed and with the same angle of elevation. So what was that thing there? I think we should just say for this one, before that, linear equation, therefore straight line. Yep. Any questions about that?
No.
Yeah, I think that's all right. Hang on. So that one, I think you're mostly good for that. We'll move on to the next thing. Okay, how about this? Hang on, sorry, I know I'm terrible. I always just seems okay. It's not too important. I think it's the one marker as well, that last one. The plane won't climb forever. Type of thing. Okay, let's try this.
Okay, so okay, do I need to do x over 5 root 2 over 2 equals to 2?
And then sub it into the other one?
Yeah.
And what would you do then?
So when I sub that in and I get my Uh, uh, or even would it be the other way around? Do I have to actually? Do I need to find out what t is so I can find the upper bound for t, which is k?
Um, you need to find the upper bound of t, which is k. T is a variable, so I won't have just one value to solve. So that one is 12.5. Okay. Minus 61.25. No. Yeah. That is x squared. No, I think I'm doing that. Okay, like, whoa. Alright, if you insist. So this one, x over that, and then we sub that in. So it'll be minus 4.9. So that's squared, so it'll be 2 over 25. 2 over 25 is 0.08. Okay. This is taking longer than I thought it would. Minus 765.625 x squared plus this one with just x. Five or 2 over 0.16. Yeah. So it's not. So 5 or 2 over 0.16. X plus 25. All right, if it makes you happier.
Do I then need to factorize this, or?
Why would you do that?
I just assumed that if I had x squared x and nothing, that was some sort of hint that I had to factorize or something.
This was root 2. If you were to get okay, what would you do after you factorize it?
So when it says k is a constant, sorry, does that mean is k like the value of when the stone is falling or something, or?
That's k. So it's launched at time equals 0 seconds. Hits the ground, whatever. So k might be 4, might be 5, might be 3.5. Some seconds later. So how many seconds until it hits the ground?
Okay, because because it's hitting the x-axis. Does that mean I need to make y equals to 0?
Is y 0 at that point? I think y might be minus 25. Is that right?
Oh,
So, yeah, let y be minus 25. Let's see how that works out. So what would you get there?
would you just put minus 25 and then put the value in we had before?
No.
Oh.
I was trying to show how not helpful that was. We're trying to find the value of t. That one was in terms of y and x. We eliminated t by doing that.
So if I do minus 25 equals to just the same thing, and then I'll just know, do I then just do 0 equals to minus 4.9t squared plus 5 root 2 over 2t?
Yeah.
And that's it.
Yeah.
Yeah.
So what do you get there?
So I get I didn't get good answers.
Go on, what'd you get?
My two values are 3.574 and minus 2.853, or even 3.57475.
Hey, let's take a look. Okay, is that, where did we go wrong? No, I was wrong. It's when y equals 0. So change c to 50.
Yeah, my two values are now 2.648.
So that's 2.65. All right, and b.
So that's just from like 0. So that's just okay. So hmm. uh, do I need to? I don't know if I need to make it into like a right angle triangle or something like in between, and then shade the unshaded area or something. But yeah,
It's not that much work. Horizontal distance is the x position.
yeah. So
when t is 2.65.
5 root 2 over 2 times 2.65.
Yep. And use answer so it rounds correctly.
Yeah. And I got as a fraction 53 root 2 over 8.
And 3 sig fig?
That'll be 9.37.
9.37 meters. Then 9.36. Did they round it wrong or did you? They got 9.36 too?
Well, I got 9.369.
And did you use answer from the previous one? Or 2.65?
2.65.
What did I tell you not to use? You cheek this
I,
man.
I did the answer, so I couldn't do it.
Oh, can you not use answer key or whatever?
Uh, I got the answer now though. 9.362. Yeah.
You cheek this man. Yeah, so that's why maybe we'll just do everything to 5 sig fig, and then at the very end unround
Yeah.
everything. Sorry, round everything. Yeah. So this one. So they take. So that's 12. Okay, so I thought that would be 0, 0. Everything up there is 0. So this is, I suppose height is 0. Yeah, all right. So when is y 0? So this is like why parametrics are used. You can separately do the y and the x. So when you want the y as 0, you can easily get that quadratic. When you want the x, you can easily get that. If we had our big equation, it would be difficult. Any questions about that one?
No.
So that one's okay, I think. Okay, tricky time. How about this?
Okay, so the motion of this is time. Am I here trying to sub in? Yeah, I think here. Do I need to do solve for t?
What is the value of t at the beginning?
I'm going to assume 0.
Good assumption.
Yeah.
We want coordinates.
And then, so I sub in, I just sub in 0 for both equations.
Yeah.
So equals to 8 cos 20 times 0, and y equals to 12 sine brackets 10 times 0 minus pi over 3.
Mm-hmm.
And so I get I got 8 as my first answer, so x is 8.
Mm-hmm.
That's when I got and my next one I got a pretty weird answer. I got like minus 0.21, minus 0.22.
Change to radians.
Right, yeah. And so shifting. Minus 6 root 3.
Okay. B. And what is 6? What is minus 6 root 3?
Minus 10.4.
So it's kind of helpful to know that where they start minus 10.4 10.4. Well, the diagram isn't great, but it's probably like one of those spots, you know. Oh no, sorry, down at minus. So right at 8 and down at minus 10.4. So it's probably this here. You know what I mean? Like minus 6 root 3 is going to be good for our working out, but it's kind of good to know that. All right, B.
I think I'll use my graphical calculator for this.
Find the coordinates of the points where the intersects its own path. Yeah. I wasn't sure how you do it, but actually, where does it intersect its own path?
Like where the 2 lines cross, or the 4 lines cross actually, but yeah.
And where is that?
Like where -4 is.
-4, y coordinate?
0.
I think that's it. Question C.
So it crosses the y-axis about 3, 3, and 3, and -3.
So this one we would need to solve. Exactly.
Yeah. Okay, so we know that x will be 0. I'm not sure if that's actually useful though. So I know that the x coordinate is 0. Equals to 8 cos 22.
Mm-hmm.
Should I then just do 0 equals to cos 22?
Yep.
Do I now need to do let 20t equals to a or something?
Yeah.
And then just do so 0 is equals to cos a.
Mm-hmm.
And so arc cos of 0 is equals to a.
Mm-hmm.
And this is still going to be in radians, isn't it?
Yep.
And so shift cos of 0 is a half pi. Yeah. Do I then need to do I then need to do 360 minus? Oh no, or sorry, 2 pi minus a half pi.
Yeah.
And so that'll be 3 over 2 pi.
So I thought we'd have to multiply. Okay, sorry. Go on.
Do I then do 20 times both of those? Or even, sorry, 20 divided, no, half pi and 3 over 2 pi divided by 20.
Yeah.
And so for 3 over 2 pi, that'll be 3 over 40 pi.
Okay.
And for half pi, that'll be 1 over 40 pi.
Okay.
Do I then just sub that t value in for both x and y?
If you sub it in for x, you'll get. If you sub it into the x equation, you'll get 0.
I'll just sub into the y equals then.
Yep.
And then I'll get probably one of the weirdest ones I've had before. So I put in 1 over 40 pi, and it gave me -3 root 6 plus 3 root 2.
Hang on. What's this thing doing? So that coordinate is 0 minus 3 root 6 plus root 3 root 2?
Yeah.
Okay.
And I then need to sub in now.
What is that roughly? Like
That is minus 3.11.
So that's probably that one there.
Yeah.
Okay.
And do I need to put in 3 over 40 pi?
Yep.
And I got 3 root 6 plus 3 root 2. And simplify, that'll be 11.6.
That's that one up there. 11.6. It actually crosses out of 4 places. We have 2 of the 4.
Oh yeah, it does. Mm-hmm.
Let's see. So remember when you had a equals a half pi and you got an additional answer by doing 2 pi minus that?
Yeah.
Any idea how you could get 2 additional answers?
Do I need to use 4 pi now or something?
It repeats every 2 pi. So you add or subtract 2 pi to each of these to get a value that's within the range.
And so should I then, so if I had 2 pi to the first one, it'll give me 5 over 2 pi.
So 5 over 2 pi, which would become 5 over 40 pi. So try that one for y.
And so if I got 5 over 2 pi, and then that for t, I think that'll just give me an 1/8 pi.
Yep.
So do I now have an 1/8 pi for both values?
What do you mean by both values?
I'm sorry, for what I need to then sub in t for y equals.
Yep.
And I would need to do 3 over 2 pi plus 2 pi, and then so 3 over 2 plus, and then that'll give me 7 over 2 pi,
Yep.
which will be 7 over 40, and then sub that into the t value for y equals as well.
Yep.
So that will give me, okay. So when I subbed in 5 over 2 pi, I got 6 root 3. I think the other coordinates will be 0 and then comma 6 root 3.
And what is 6 root 3?
10.4.
Did you? So you said 5. You subbed in 5 over 2 pi. Is that what you subbed in?
Yeah.
Should have been 5 over 40 pi.
Oh yeah, I'm sorry. And so that'll give me. So I think it's going to cover all the 3 root 6 and 3 root 2s. This time I've got 0, then 0, and then 3 root 6 minus 3 root 2, which simplified is 3.11.
So that's positive 3.11. Aha. So what do you think the one down here is then?
11.6, yeah.
Minus 11.6. Let's take a chance. Let's make sure first. So yeah, 3 root 6 plus 3 root 2 minus 3 root 6 plus 3 root 2. Oh, I don't know. 3.11, 11.6 minus 3.11. And minus, yep. Okay, D.
So okay, so that's so t is time. They said how long, so I'm guessing I need to find out some sort of t value here.
Yep.
Do I need to? Like, if I sub in my highest x or y value, would that give me the Would that give me the longest time for t or something, or?
Nope. Sine and cos are cyclical, so it's gonna come back around.
I'm not sure.
So our little man is gonna go on his ice skating thing, and then we need to see the amount of time it takes for him to go all the way back around and back to the start again.
Yeah.
So you would have to say, how long will it take for the x coordinate to return to 8, let's say. Or you could do the y coordinate to return to that difficult one, but I'm not doing that one. So when time is 0, his x coordinate is 8. How long until he returns to the same coordinate?
So am I just doing 8 equals to 8 cos 22?
Yeah. That's it.
And then if I put that into my calculator, I got quite a number of values.
There's an infinite number of values. Was one of them 0?
One of them was, yeah.
So that's our initial one. So what do you think?
Do I need to now put like 12 in for my y value, and then whichever one y value is the same as the x value, that's the t value?
I like your thinking. What is the one after 0?
A tenth pi.
And so is that when he comes back around? How could you check if that's the right one?
Would I need to sub in 8 cos 20 times tenth pi, and then it should be equals to 0? Or
it'll be equal to 8.
8, yeah.
Doesn't tell you anything. At 1/10 pi, which is 0.341 or something. What is the time unit? Minutes. So about a third of a minute later, about 20 seconds later, he would return back to the start. Actually, no. That t that you just got, a 10th pi, if you subbed that into the y, what you would expect is to get minus 11. What you would actually get is plus 11, because when he returns to have an x coordinate of 8 is up here. So he sets off, he has an x coordinate of 8. We want when he returns to having an x coordinate of 8 again, but actually he temporarily has an x coordinate of 8 here. So which time answer do we need?
Is it between 0 and 8?
It's the next one. So what's the one after 1/10 pi?
A fifth pi.
So it should be, let's see, t equals 1/5 pi, and you could do 1/5 pi times 60 to get what it would be in seconds or something. 1/5 pi minutes, basically. So don't overanalyze these. So he in the beginning he has an x coordinate of 8, yeah.
Yep.
When he does a full loop, he will return to have an x coordinate of 8. So you would just say, okay, what are all the times where he has an x coordinate of 8? It's cosine. It's going to keep going round and round and round. So there's an infinite number of them. So initially he has an x coordinate of 8 when t is 0. Then it says he has an x coordinate of 8 at 1/10 pi. And so you think, he returned back to where he was, x coordinate of 8. But actually, that's up here. And so you have to do every second one is every time he does a lap, I believe. D 2 pi over 10. So it's 1/5 pi, and it's roughly 38 seconds. They times the by 60. Let's see. Any questions about that part of it? Question D?
No.
Oh, tricky. But other than that, I think it's all right. Let's see. All right, better do it.
Okay, so so they're basically asking me for the x, I think.
Yeah.
And so I I know what I need to do. I need to sub in minus pi over 2 and pi over 2 to get the width of the x values.
That's crazy enough to work. Go on, try it.
Go.
Oops. So what is it?
Yeah, I didn't get good value. Yeah, that's what I got as well.
For which one? Negative?
Yeah, minus pi over 2.
3.725.7. And so this one here, I believe, would be the negative version of that. Have a crack at it. What would be that width then?
Oh, it'll be 3.7527 plus 3.7527, which will be about.
What do you mean about? Answer times 2.
7.45.
7.45. 7.45. Great. B.
I'm guessing they're asking me for like the vertical line below the x-axis. I think.
That's one way to do it. So this length here, is it?
Yeah.
The vase is filled up to the level. No, at the surface level.
So it'll be horizontal. Yeah, it'll be.
Yeah.
Would the radius not just be 3.7527?
So that's this length here. Radius looks a bit bigger. Radius looks longer.
Yeah. Um. Um. Do I need to sub in like 0 for y for y?
Perfect.
And that will give me minus 8 divided by minus. So that'll give me a half equals to cos 2. And then I'm guessing I don't need to solve for t here.
I'm guessing you do need to solve for t.
So arc cos of a half equals to 2. And that's a third pi.
Okay.
And so if I sub in a third pi in for the t values for x equals.
Yep.
And that will be and I got about minus 8.86.
And so radius?
Do I need to divide that by 2?
If my understanding is correct, so we said here y is 0. I think we got this one here. At this point, y is 0, t is a third pi, and x is minus 8.86. You would double it to get the diameter.
So is the radius just going to be 8.86 then?
Yep.
Okay.
Centimeters and c.
I'm guessing it's going to be the area of a cross section here.
Doesn't ask for area, I don't think.
It's asked for the depth. Does that have to do with volume or something? Or?
No. Where is the deepest point in the face?
Like at the bottom of the y axis, yeah.
Mm-hmm.
And so that means that x is 0.
Yep. Use calculator to solve that.
Yeah. And so I got a couple of values. I got 2. Actually, I got 3.
Go on. Which one looks good?
The only one that's like exact is 0.
When time is 0. Okay. What would you do with that?
Sub that into y equals.
Mm-hmm.
And so that will be 8 minus 16 cos 0. And I got minus 8.
Minus 8 centimeters. Looks alright. Let's take a look. Misleading diagram. What's that about? We got 8 centimeters. Yes, misprint. They gave diameter. I emailed them about this. I taught it with a previous student, and they emailed me back saying, "Yeah, you're right." And so in future editions of the book, they'll change it. This is the diameter. It took me a long time to figure it out. They did double it and then rounded it to 3 sig fig, and then 7.45. Great. So, like other stuff, what was it? The width of the opening, you did no help from me. You subbed in the max and min t, got that, doubled it. B, the only thing I helped you with was you said you would have doubled this, but that would give you the diameter.
Yeah.
Other than that, and you solved it manually, so in case they wanted an exact value. And then C, just we were pressed for time, I said calculator. Worked out anyway. T is 0, and so you sub that in, and that gives you the Y position. So yeah, don't overthink these. This gives you the X position, this gives you the Y position. Find out one, sub it into the other. You know, you have to, T is like the common thing that you have in common, so you have to solve for T in 1. Like when Y is 0, what is T? And so with that value of T, what is X? And that's how you connect them. So there's lots and lots of these questions, but it's basically just, this is an equation, and it's the easiest way to represent it is with 2 separate parametric equations. So this is a graph of an equation, and it represents something in real life. So the motion of a plane, a bowl, and you just have to use all your usual trig stuff to solve it. Any questions in general?
No.
So what do you give yourself there?
I think maybe a tick. Yeah.
I'm happy. So now we're definitely finished that one, and we're on to differentiation for next time, if that's all right.
Yeah, that'd be good. Thanks.
Grand. Any questions for me in general?
No, I don't think so.
Okay, yeah, I'm happy. My parametrics is done. Well, yeah, well done, Andrey. You did great. I look forward to chatting again next time.
All right. See you on Friday. Cheers. Thanks.
All right, take care. Goodbye.